Okay, double and half angle identities. So here are your double angle identities. These are important for calculus. I'm not going to stress memorizing them. You might have to next year. I don't remember if I memorized these in calculus or not, but just have them somewhere you can reference, okay? So if cosine of theta equals 8/17 and 3 pi halves is less than theta, which is less than 2 pi, we need to find sine of 2 theta. So this right here is telling us which quadrant it is in, okay? So that's telling us that it is in the fourth quadrant. And we can draw a triangle here because cosine is adjacent over hypotenuse. So that means the adjacent side there's 8, the hypotenuse is 17. Okay, so if you have a right triangle with a missing side, that's where you use Pythagorean theorem. Okay, so here this is going to be 8 squared plus b squared equals 17 squared, which is 64 plus b squared equals 289. B squared equals 225, so b equals 15. Now, since this is in the fourth quadrant and it goes down, that's going to be a negative 15. And I know you can't have a negative length, but since we're on a coordinate plane, if we are going down below the x-axis, it has to be negative, okay? Now here, sine of 2 theta is 2 sine of theta cosine of theta. So I already know what cosine is. We know that sine is negative 15 over 17 because sine is opposite over hypotenuse. So the opposite side there is negative 15, the hypotenuse is 17. So that means this is going to be 2 times negative 15 seventeenths times 8 seventeenths. And I just used my calculator here. And I got negative 240 over 289. So that means the sine of 2 theta equals negative 240 over 289. Okay? This one. So if sine of theta is negative 1/3 and theta is between pi and 3 pi halves, we need to find tangent of 2 theta. So that's in the third quadrant. Again, we have to use Pythagorean theorem. To be honest, if I'm being honest, I've never used Pythagorean theorem in the real life. But I also don't know much about the house that I own. When things break, I have to call my friends this just broke, please come help me. There's lots of real life things that I'm not super good at, but I am good at math. I'm going on a weird tangent here, but you still need to know Pythagorean theorem if you're going forward in math. And you guys are in honors math, so you are going forward in math. So hopefully you don't look like this guy. But let's just use it here. So a squared plus negative 1 squared equals 3 squared. A squared plus 1 equals 9. A squared equals 8. So a equals the square root of 8, which if you break that down, that's the same as 2 square roots of 2. Okay, so that means that is negative 2 plus the 2 because we went backwards on the x-axis. Okay. So if we have tangent of 2 theta equals 2 tangent of theta and then 1 minus tangent squared of theta, which means we need to know what tangent is. So tangent is going to be negative 1 over 2 square root of 2, which is 1 over 2 square root of 2. If we rationalize that, that's going to be the square root of 2 over 4. And then we can plug it in. So 2 times square root of 2 over 4, 1 minus square root of 2 over 4 squared. So that's going to be on top, you get square root of 2 over 2. On bottom, you get 1 minus 2/16. Well, that 2/16 is the same as 1/8. So square root of 2 over 2 and then 1 minus 1/8. Can change that 1. So 1 minus an 1/8. If we can just change this. I just did this quick in my head, I think. But 8/8 minus 1/8. That's how you get the 7/8. Okay, so square root of 2 over 2 divided by, just write it as a division problem, 7/8. Now, yeah. So I heard you like fractions, so I put a fraction in your fraction, and you can flip while you multiply. Yes, flip it and multiply it. So that's going to be square root of 2 over 2 times 8 over 7. which 2 goes into 8 4 times, so that's 4 squared to 2 over 7, which means that the tangent of 2 theta is 4 squared to 2 over 7. Okay. This one, tangent of theta equals negative square root of 7 over 5. And it's between pi halves and pi. We want to find cosine of 2 theta. So that's in the second quadrant. Tangent is opposite over adjacent. And I knew that this side was our negative side because that is the side that went to the negatives. This side went up, so it has to be positive. And then again, we have to use Pythagorean theorem. So here we have negative 5 squared plus negative 7 squared equals c squared. So that's 25 plus 7 squared equals c squared, which is 32 equals c squared. So c equals the square root of 32, which then you get c equals 4 square roots of 2. So that hypotenuse there is 4 square roots of 2. Okay, and it doesn't matter which one we use. I'm just going to use the top one because it's on the top. But you could use any of these. But we can find cosine and sine. So sine is square root of 7 over square root of 4 squared to 2. And cosine is negative 5 over 4 squared to 2. And since here, these are both being squared, I'm not going to worry about rationalizing this because when we square it, the square roots are going to cancel anyways. So that means we're going to have negative 5 over 4 squared to 2 squared minus square root of 7 over 4 squared to 2 squared, which is 25 over 32. Because so if you square this, so that's the same as negative 5 squared over 4 square roots of 2 squared. This is 25. If you're to square this, that's the same as 4 squared square roots of 2 squared, which is 16 times 2, which is 32. And then 7 over 32, 25 30-seconds minus 7 30-seconds is 18 30-seconds, which reduces to 9/16. So cosine of 2 theta is 9/16. Okay, now let's get into the half angle identities. Again, you don't need to memorize these, but do have them where you can reference them. And then to determine the sign, because if you look like at these three right here, they all have this plus minus, plus minus, plus minus. To determine the sign, you have to determine the quadrant the half angle lies in. So like 67.5. Well, that's in the first quadrant because the first quadrant is from 0 to 90. So if you remember, all students take calculus, or I found this all science teachers crazy. It doesn't even say are crazy, but all science teachers are crazy. You'll remember that all the signs are positive in the first quadrant, so that means that cosine is positive in the first quadrant. Okay, but this is our half angle, and we need to use this, obviously, because this is a cosine. But we need to get it in the form of theta over 2. So we need to figure out, well, if 675 or 67.5 equals theta over 2, to figure out what theta is, I just need to multiply by 2. And we end up getting 135 over 2. 135 over 2 is the same as 67.5. And we know that this is positive. We're using that one, but we know it's positive because it's in the first quadrant and cosine is positive there. Then again, we have to use our unit circle. Nobody got time for that. Except for we do because we have to, right? So cosine of 135 is, the x value at 135 is negative square root of 2 over 2. So this is going to be square root of 1 plus negative square root of 2 over 2 all over 2, which is going to be, let's just change that to be 2 over 2. So 2 over 2 minus square root of 2 over 2. There's a lot of 2's right there. So that's going to be square root of 2 minus the square root of 2 over 2 divided by 2. Whenever you have a fraction in a fraction, I always divide it and then flip it. So then that's going to be 2 minus the square root of 2 over 2 times a half, which is 2 minus the square root of 2 over 4. You can square root the top, square root the bottom, so that's square root of 2 minus the square root of 2 over the square root of 4, which the square root of 4 is 2. Okay, so that means the cosine of 67.5 is the square root of 2 minus the square root of 2 over 2. Let's do this one. So tangent of 175, that's in the second quadrant, which tangent is negative in the second quadrant. To find our whole angle, we just take that 157.5 and multiply it by 2. You get 315. So it's the same as tangent of 315 over 2. And we can use any of these. It doesn't matter which one you choose. Okay? And it looks like I chose the second one. Okay? If I can avoid the square root, I'm going to avoid the square root. Okay? I don't really like the square roots. So here, this is going to be 1 minus cosine of 315 over sine of 315. So our unit circle, 315, well, the cosine of 315 is square root of 2 over 2. The sine of 315 is negative square root of 2 over 2. Get that common denominator on top, so you get 2 minus the square root of 2 over 2. On the bottom, you have negative square root of 2 over 2. Well, since, remember back to the last video, when you have fractions like this and they have the same denominator, you can just cancel the denominators. So you get 2 minus the square root of 2 on top, and then negative square root of 2 on bottom, which we can rationalize this, and I just move that negative out front. Now we can rationalize it, multiplied by square root of 2 to top and bottom. So we get negative, and then 2 square root of 2 minus 2 over 2. Which that 2 goes into this and cancels that and that. So we're left with negative, and put that in parentheses because that negative has to distribute. Square root of 2 minus 1, which is negative square root of 2 plus 1. So that means tangent of 157.5 is negative square root of 2 plus 1. Sine of 11 pi 12ths, change it to degrees, so that's sine of 165. We need to figure out what the whole angle is here, so if we just do 165 times 2, even before we do that, this is in the second quadrant. Sine is positive in the second quadrant. And now we can multiply by 2 and you get 330, so sine of 330 over 2, which we're using this right here. And we know it's positive, so it's going to be square root of 1 minus cosine of 330 over 2. Well, the cosine of 330 is square root of 3 over 2. So this is going to be square root of 1 minus the square root of 3 over 2, which is the square root of 2 over 2 minus the square root of 3 over 2 over 2. So that's square root of 2 minus, or 2 square root of 2 minus the square root of 3 over 2. Over 2. Flip and multiply. So first write it as a division, and then we're going to flip it. Yep. I don't know if you watch, what's that show called? Rick and Morty. I actually I like Rick and Morty. I think they're really brilliant, and I think it's funny that they have all these alternative universes and stuff. I think it's great. I think it's a great cartoon show, even though I don't know if I should be encouraging you to watch Rick and Morty, but yeah. So then here, flip and multiply. So that's 2 minus the square root of 3 over 2 times 1/2. So that's the square root of 2 minus the square root of 3 over 4. Break it up. We know that the square root of 4 is 2. So that means that the sine of 11 pi 12ths is the square root of 2 minus the square root of 3 over 2. Okay. Now this one's a teeny bit different. So say that we're given that the cosine of theta is negative 3/8. And it's in the second quadrant. We need to find sine of theta over 2. Well, first, they tell us it's in the second quadrant, and they're telling us we need to find sine. So in the second quadrant, sine is, no, wait, why did I say it's negative? Sine is positive. Sine is definitely positive in the second quadrant. Scratch that positive. My bad. Sine is positive. Okay? Hopefully I didn't do this whole problem wrong, or that's like super disappointing. So we have this. Oh, see, look, I didn't even do it. I don't know what's going on. Okay, so we have 1 minus the cosine of theta over 2, all under a square root. Well, we need to figure out, oh, no, we don't. We already know cosine. So then we can do 1 minus 3/8, 1 minus negative 3/8 over 2, which is double negatives a positive, and that's 8/8 plus 3/8 over 2. So that's 11/8 over 2. Divide and then flip, so that's square root of 11/8 times 1/2, which is the square root of 11/16. Break it up. Square root of 16 is 4. So that's the square root of 11 over the square root, or over 4, not square root. So that means that sine of theta over 2 is square root of 11 over 4. Okay, this one, so we're in the fourth quadrant, my bad. And in the fourth quadrant, tangent is negative. And it doesn't matter which one we use. Let's use the last one just for fun. I always avoid the square root if I can. Okay. So first we need to figure out what that missing side is, which if you just use Pythagorean theorem, you get that it's 5. So then here for this equation, we know sine. We also need to know cosine, which is 5/13. So that means that the tangent of theta over 2 is negative 12/13 plus 1, over 1 plus 5/13, which is negative 12/13 over 13/13 plus 5/13. So negative 12/13 over 18/13. Remember, if you have the same denominator on top and bottom, cancel it. So you get negative 12 over 18, which is negative 2/3. Okay. This one, so we have tangent of theta is 4 square root of 3. It's in the third quadrant, and we need to find cosine of theta over 2. So third quadrant, cosine is negative. So here, we're using that one. We don't have options, really. That's the only one we can use. And tangent is opposite over adjacent. But I know that, like, if you go back and down here, they both have to be negative, which would make sense that it ends up a positive. Okay, and that's why I put the 1 here. And that's negative 4 square root of 3. Okay. Pythagorean theorem, you end up getting 7. All I need here is cosine. So cosine is negative 1/7, which is pretty nice for us. Now we don't have a square root anymore. Okay. So then this is going to be the cosine of theta half equals negative square root of 1 plus negative 1/7 over 2. So that's 1 minus a 7th over 2. 7/7 minus 1/7 over 2. 6/7 over 2. Write it as a division and flip it. So that's 6/7 times a half, which is 6/14. So that's going to be the square root of 3 over 7. Which break it up and then rationalize it. This is an easy rationalization, so that's negative square root of 21 over 7. So that means the cosine of pi halves equals negative square root of 21 over 7. Okay? Oh, yeah, and we're done. I don't know if you understand it quite yet, but, like, we'll get there for sure. And hopefully you'll have this moment where Oprah is like, yes, like, this is awesome. Handing out everything. I don't think I'll ever be like Oprah and, like, just give away stuff. I'm not rich. I chose to be a teacher. So, yeah. Anyways, okay. Yes, I miss you guys. I hope everything's great. Okay, bye.